Hi everyone, I'm Shubham. I'm a master teacher at Vedantu. We are discussing JEE Advanced 2019 Paper-1 Mathematics, and the question for this video is this. Let M be a matrix having these four elements equal to alpha I plus B M inverse, where alpha is some function of theta, alpha of theta, and beta is again a function of theta, are real numbers, and I is the 2 cross 2 identity matrix. If alpha star is the minimum of the set alpha of theta, where theta varies from 0 close to 2 pi open, and beta star is the minimum of the set beta of theta, again theta varying from 0 close to 2 pi, then the value of alpha star plus beta star is. There are four options and it is a single correct type question. Now solving this is very simple if you know something called Cayley-Hamilton theorem. So as per Cayley-Hamilton theorem, since this matrix M is an order 2 matrix, it satisfies the equation M square minus trace of M times M plus determinant of M times identity matrix equal to null matrix. And what we have been given is M is equal to alpha times identity matrix plus beta times M inverse. If I multiply both sides by M, whether you pre-multiply or post-multiply, it would not matter in this case. You get M square is equal to alpha M plus beta I, identity matrix. So essentially it becomes M square minus alpha M minus beta I equal to null matrix. And as you compare with this equation, which we have got using Cayley-Hamilton theorem, you get alpha is trace of M and beta is minus times determinant of M. Now, what is trace of M? It is sum of the diagonal elements. So it is essentially sine to the power 4 theta plus cos to the power 4 theta, which you can write as sine square theta plus cos square theta whole square minus 2 sine square theta cos square theta. So basically it becomes 1 minus 2 sine square theta cos square theta, which you can also write as 1 minus sine square 2 theta by 4, or rather by 2, because it is 2 times, so you may say by 2. So here minus times determinant of M. What is determinant of M? This is very simple. It is sine to the power 4 theta cos to the power 4 theta minus, and this minus would become plus. Basically I have taken minus common from minus 1 minus sine square theta. So it essentially becomes 1 plus sine square theta 1 plus cos square theta. If you see carefully, this essentially becomes sine square theta cos square theta whole square plus 1 multiplied 1 is 1, sine square theta plus cos square theta becomes plus 1 more, plus sine square theta cos square theta. So again you may write this as what? Minus 1 plus 1 is 2, sine square theta cos square theta is essentially sine square 2 theta by 4, plus sine square theta cos square theta is sine square 2 theta by 4, whole square becomes sine to the power 4 times 2 theta by 16. So sine to the power 4 2 theta by 16. Now what we want is alpha star plus beta star. Alpha star is the minimum value of alpha as theta varies from 0 close to 2 pi open, and beta star is the minimum value of beta as again theta varies from 0 close to 2 pi open. If you see carefully, alpha and beta both are depending on sine square 2 theta, so to speak, and both would be minimum when sine square 2 theta is maximum. Why? Because those terms are coming with minus sign, and sine square 2 theta maximum value is 1, which it will definitely take as theta varies from 0 close to 2 pi open. So by that we can say the minimum value of alpha as you put sine square 2 theta to be 1 becomes half, and the minimum value of beta, which is beta star, it becomes minus 37 by 16, which you may check it out when you put sine square 2 theta to be 1. So minus times 2 plus 1 by 4 plus 1 by 16 essentially is minus 37 by 16. And what we want is alpha star plus beta star. As you add them, you get minus 29 by 16. So my answer essentially would be C. Now there is an alternate to this question also. There is an alternate solution. What if you don't know Cayley-Hamilton theorem? Then you may go the normal course. You may find M inverse, which essentially is adjoint of M divided by determinant of M, and then you may compare the elements on the both sides and hence find alpha and beta in terms of theta, and hence find the minimum values that alpha and beta take to ultimately find the sum of those minimum values. So my answer is C, minus 29 by 16, and the other solution let me just show you through the typed version. So here to find M inverse you would need determinant of M. So you can find determinant of M like this, just as what we have already done, because beta turned out to be minus times determinant of M. Yeah. And adjoint of M is very simple. Since M is 2 cross 2 matrix, you just swap the diagonal elements and the non-diagonal elements you just put with minus sign. So ultimately what you get is M is equal to alpha I plus beta M inverse, which is adjoint of M divided by determinant of M. Now as you compare the elements on the two sides, sine to the power 4 theta is equal to alpha plus beta by determinant of M cos to the power 4 theta, and minus 1 minus sine square theta is equal to 0 plus beta by determinant of M times 1 plus sine square theta. Now this 1 plus sine square theta you may cancel out on both sides, and essentially you get beta equal to minus times determinant of M. Obviously because 1 plus sine square theta can anyway never be 0. Yeah. So beta turns out to be minus times determinant of M, which we have anyway got using Cayley-Hamilton. And when you put beta to be minus times determinant of M, alpha essentially becomes sine to the power 4 theta plus cos to the power 4 theta, which again we had got in our previous method. Now you may minimize the two and add the minimum values of the two to get the answer. Now you may wonder, what if I would have considered this element and this element? You would have got the same thing. 1 plus cos square theta is equal to 0 plus beta by determinant of M times minus 1 plus cos square theta effectively. And cos to the power 4 theta is equal to alpha plus beta by determinant of M times sine to the power 4 theta. So essentially by comparing this element you would have got beta to be minus times determinant of M, and by considering this element you would have again got alpha to be sine to the power 4 theta plus cos to the power 4 theta after having put beta to be minus times determinant of M. So my answer ultimately is C. Thanks for listening. Stay tuned for the next question.